ionic radius, we're going to be looking at the size of an ion. Now remember, an ion is a charged particle. It has gained or lost electrons. You cannot gain or lose protons, that's a different element. But if you've gained or lost electrons, you have become an ion. And some synonyms to ionic radius would be ionic radii, if you have more than one, or you may see it listed as ionic size, so that you're looking at the size of an ion. Now is a good time to review. Remember, if you have a cation is positive, and if you have an anion, that is negative. Now, in a positive ion, electrons have been lost. Okay, and that makes them positive. And if you have an anion, electrons have been gained. So if you think about it, the size of an ion in comparison to the ion, you would assume that if it's a cation and you have lost electrons, the size would get smaller. And if you have an electron and it has gained electrons, the size would get bigger. So you're going to need to think about ionic size in terms of the distance from the valence electrons to the nucleus, and where are those valence electrons when you gain or lose electrons. A thought to consider is that just like with the atomic size, you don't know definitively exactly where that electron is because it's always moving, but you do know whereabouts it is as far as the shell, if there's multiple electrons. So you're going to be looking, the ionic size is going to also consider when it's bonded with something else. So you're not going to just pick up a sodium ion or a chlorine ion. You're going to look at them combined together and figure out where they where the distance of the orbitals overlap.